What's it got down his throat?
I would suggest it's feeding him oxygen.
Paralyzes him, puts him in a coma, and keeps him alive. Now, what the hell is that?
That, my friends, is a scene from the classic science fiction thriller Alien by Ridley Scott that debuted in 1979. It's a fantastic movie, though absolutely terrifying, for it depicts a parasitoid that is using humans for its host. Well, hey everyone, I'm Ken Catania. I work at Vanderbilt University, and this movie is a companion to my recent book on the art and craft of doing science. And in this video, I'm going to continue to talk about how some discoveries unfold. I'm going to keep with the subject of emerald jewel wasps and their cockroach hosts, so if you haven't watched the last video, I recommend doing that. I am actually going to talk about how the movie Alien was important for the discoveries that I'm going to describe during this video. And I'm also going to draw some connections with the father of modern astronomy, Galileo, and some of the discoveries and what he did to make those discoveries. I'm going to sort of draw all this together to talk about the practice of doing science. But before I go any further, I want to give a warning. I teach about this subject in these experiments on Halloween because it's truly creepy. I think creepier than the movie Alien. So if you're weirded out and creeped out by cockroaches, grubs, and one animal eating another animal alive from the inside, this may not be the video for you. Though I think I might have just guaranteed you're going to keep watching. So if anyone's wondered why there's an alien facehugger on the wall behind me, this is the reason. When I teach about these parasitoids, I go back and forth between the movie Alien and what actually happens with the emerald jewel wasp to sort of give a human equivalent, to give you a feel for the biology. And when I do that, part of the art of doing that is trying to find scenes in the biology of the emerald jewel wasp cockroach interaction that parallel what's going on in the movie Alien. And what you saw at the beginning was the character Kane, who had had that facehugger stuck to his face, and the alien was essentially depositing something within his body, as many of you may know. Now, what they did there was scan the internal organs of Kane to see what was going on. And so I decided to scan a cockroach that contained the developing larva of an emerald jewel wasp. So let me go back to the biology of the emerald jewel wasp. I'm going to show you first how the emerald jewel wasp enters the cockroach, because recall that the egg has to be in just the right place in order for the larva to survive. And you're going to see why. And then I'm going to go from that to the view of a whole cockroach with this parasitoid inside of it, a lot like what's going on with Kane in the movie Alien. All right, to pick up on the biology of the emerald jewel wasp and the cockroach host from the last video, or if you haven't seen the last video, I'll just point out that that's an egg left by the emerald jewel wasp on the second leg of the cockroach. And that is big trouble for the cockroach, because shortly that egg will hatch, and then there's a small grub larva there, and the larva will bite through a soft membrane at the top of the leg of the cockroach and start to feed on blood. Using that as a nutrient, it will start to grow on the outside of the cockroach, and you're going to see this in the time-lapse video, which is actually a couple of days of development sped up very quickly. And then what the larva is going to do is bite through that soft membrane and crawl inside of the living cockroach to then start to eat the cockroach alive. And here's that view of the emerald jewel wasp larva eating the cockroach alive from the inside. This is not what you want to see on your medical scan, that there's a creature inside of you eating you alive. So in a way, this was mission accomplished. I got the view that was similar to what they show in the movie Alien to sort of highlight how the biology between the science fiction and reality is actually somewhat similar. But that's not the end of the story. Because I focused in to look in this area where not many people have ever looked before, I started to see things and I made some discoveries. And that's what I want to tell you about next. And to do that, we have to go all the way back to the 1880s and first tell you about the commonly held view about how many parasitoids feed on their host. So there was a very accomplished entomologist, Henry Fabre, and he was observing how wasps that parasitize spiders, how their larvae feed in a very special way. And I'm going to paraphrase from the French translation. Basically, he pointed out that the ruling feature in this scientific method of eating proceeds from parts less to parts more necessary to preserve a remnant of life. Basically meaning that the larva of the parasitoid will tend to avoid the vital organs of their host, very logically so they don't kill their food source prematurely while they're feeding on it. And to tell you why that's so interesting when it comes to the emerald jewel wasp, I have to give a little demonstration of the anatomy of a cockroach. So I have this giant Halloween cockroach here to demonstrate with, and what I've done is I've taped a marker on the back because the heart of a typical insect, and certainly in the cockroach, is basically called the dorsal vessel, and it runs just under the cuticle, basically in this position. And what I've done in order to observe the larva as it feeds is just shined a light through the bottom of the cockroach and then given a microscopic view from above. And that's where you saw that image of sort of the so-called scan of the cockroach body with the larva inside. But I discovered along the way, by watching that happen and just setting things up, that unusually the emerald jewel wasp larva goes straight for the dorsal vessel and consumes a portion of it right away, essentially destroying that vital organ, an organ which Fabra and others have described as something being preserved by most parasitoids. And so basically the emerald jewel wasp is sort of flipping the script on what goes on with the typical parasitoid. And that's very interesting and worth documenting. So I, of course, wanted to check, does this happen in every case? And I wanted to get a better view of it. So I sort of refined my view and my optics and my lighting and so forth. That's something that you do in science. You repeat your observations multiple times. Hopefully you improve your observations if you think you might have found something interesting. That's what I started to do. And that is also a practice that leads to additional discoveries. And for that, I have to point out that the respiratory system of insects is formed by a bunch of tubes, these little tracheae that radiate around through the body of the cockroach. They're very different from typical lungs, for example, in mammals. And those tubes contain the air through which oxygen diffuses, and the larva also destroys these. Now, I'm going to show you an annotated movie of this, and I'll describe what's going on as you view it. Okay, so the dotted line area, that box represents the field of view. And there is the larva on the leg of the cockroach. There's the heart chamber that we're going to be looking at during this video. And there are some respiratory trachea of the respiratory system of the cockroach. And now this is greatly sped up. This was a time-lapse video that is sped up. And the larva is just eating its way straight towards the midline, the upper midline of the cockroach, and it goes ahead and eats that dorsal vessel right away very early on during its feeding sequence. Okay, that was an example of the cockroach heart being destroyed very early on in the feeding sequence of the emerald jewel wasp larva, and that happens every time. But the thing I love about science is the more you look, the more you see. So there was another unexpected discovery. And for this, I have to return to the trachea and remind you that as the larva is entering the cockroach, it's chewing through those respiratory tubes, those tracheae that hold the air that the cockroach uses for its own respiratory system. And that releases air bubbles into the body cavity of the cockroach. And the emerald jewel wasp larva actually takes advantage of this. And for this, I'm going to use a prop to demonstrate what's going on. So this is a plush chestburster from the movie Alien. And so what the larva is doing when it enters the cockroach, it's always canted to one side. And these blue dots I put on here represent the spiracles that are the opening to the larva's own respiratory system. And what the larva does is associate these openings to its own respiratory system with the air bubbles and actually suck these in. So it's actually taking advantage of the respiratory system of the cockroach to breathe the cockroach's air. And you have to see this to really appreciate it. So I'm going to go back to the movies and I'm going to show you how this association is made. And for that, I want to also point out that the spiracles of the larva will look like these sort of short tubes in the movie that have an opening, and you'll be able to see how they're associated with the air bubbles. Okay, so here's a view through the dorsal cuticle of the cockroach looking at the feeding emerald jewel wasp larva, and notice when this starts to move how the larval spiracle becomes associated with that expanding and contracting air bubble. Now, that air bubble wouldn't normally be there. It's there because the larva has chewed through the respiratory system of the cockroach, and it is essentially stealing the air of the cockroach. Now, how do we know that? Well, watch what happens when the spiracle becomes associated with a separate free-floating air bubble. It sucks that air bubble straight in. So it is definitely using its own respiratory system to suck in air from the cockroach broken respiratory system. And that is pretty remarkable. Well, that's a pretty neat trick that the larva has to actually use the air from the host in order to aid its own respiration. And nothing quite like this has been reported before. So one of the obvious questions is, why is this going on in the case of this jewel wasp larva? Well, the obvious explanation is that it is ravenously and quickly eating the host, much more quickly than is typical for most parasitoids, and therefore it does not need to preserve the life of the host, because the host is going to die anyway very quickly. And at the same time, because its metabolism is so high for feeding so quickly, it needs to be breathing and taking advantage of the air that it can get while within the body of the host, more so than would be true of the typical parasitoid. So if you want more details about this discovery, about the data, and about the implications, I put a link to the published paper in the description below. But now I want to end on a much more general note. So if you're following along in the book, you'll know that I emphasize the importance of focused attention for making unexpected discoveries. One way to focus your attention is to work on a scientific puzzle. Another way is to search for art in your data, to look for aesthetic views of your study system. And I'm actually going to suggest, and I believe, that me trying to find a view of an emerald jewel wasp larva eating a cockroach alive from the inside that is comparable to what happens in the movie Alien is actually an artistic endeavor. That is what focused my attention on the system, and that in turn led me to notice that the heart was destroyed very early on in the feeding sequence, and then trying to refine the view of that happening is what led me to notice and discover that the larva is tapping into the respiratory system of the cockroach as it feeds on the host. But there's also a less esoteric and more practical lesson in the discovery that I just described. Remember in the beginning, I said I was going to talk about Galileo, the movie Alien, and the process of scientific discovery. So how does the father of astronomy, Galileo, fit into this story? Well, in 1610, Galileo did something very simple. He took a piece of technology, his telescope, and he aimed it in a new direction. He aimed it at Jupiter. And he discovered Jupiter's moons, and those moons were orbiting Jupiter, not the Earth. So that was one of the reasons that our view of the universe changed from an Earth-centric view with everything orbiting the Earth to a universe where objects orbit other objects, which is, of course, what's really going on. So how does that relate back to my study? Well, if you recall, all I did in the course of the study that I just described was to take a cockroach under some interesting conditions, shine a light through it, and put it under a microscope. I basically aimed technology in a direction where it had not been aimed before, and there were discoveries to be made by that simple act. And that can definitely be a useful strategy in science for making discoveries, aiming technology in a new direction. So I'll leave you with that thought, but I'm also going to leave you with a last view of the emerald jewel wasp. I'm going to give you a view of one of the jewel wasps finally hatching out of its cockroach host. And you may recognize the soundtrack from the kitchen scene on the Nostromo in the movie Alien.
Oh, God!
No, no, no!